In this video, you'll learn how to create and customize stairs in ideCAD. We'll cover choosing different stair types, adjusting risers and treads, editing appearance and railings, and working with the Stair Edit dialog. You'll also see how to deform stairs, create custom stairs with paths, and build a complete U-shaped stair with landings. By the end, you'll know how to design stairs of any shape quickly and precisely. Let's continue with the Stair command. It is used to create the stairs of the project placed on the base story. Once the command is activated, the Stair toolbar appears, featuring tools such as Create New Stair, Add Stair Area, Deform Stair, Move Stair Text, Show Hide Railing, Change Baluster Count, etc. On the far right of the toolbar, the Settings icon is located. Clicking this icon opens the Stair Settings dialog. In this dialog, the first step is to select the stair type. ideCAD includes several predefined stair types, such as single flight, multi-flight, winding, with landing, and without landing. Depending on the selected type, the stairs plan view and 3D perspective view are displayed on the right. In the perspective view, zooming in, zooming out, and rotating are possible to examine the stair in more detail. In this example, we will proceed with a U-shaped stair. After the stair type is selected, the construction type can be defined in the Construction tab. In this section, options such as ramp, stringer, and the form of the stair slab can be selected. Parameters related to the riser, such as tread covering thickness, riser covering thickness, and nosing length at the front of the tread, can also be adjusted. Additionally, settings such as stair ID, elevation, and baluster face count can be modified. The Appearance tab is used to configure display settings, allowing control over how the stair appears in both the plan view and the 3D model. From this tab, line type, color, and 3D material options can be defined. Label settings can also be configured here. Stair measurement units can be adjusted from the Units tab. In the Handrail, Baluster tab, different profile types for stair railings can be selected. The stair railing will be generated based on the chosen profiles. This section includes sample cross-sections of various handrail and baluster designs. Let's select one profile cross-section for both the handrail and baluster. After completing the stair settings, click the OK button. A preview of the stair will appear on the screen. By pressing the spacebar, the insertion point of the stair can be changed, and its position can be reviewed in the perspective view. Once the stair is moved to the desired location and clicked, the preview becomes fixed. Then, by moving the mouse, the stair can be rotated and placed accordingly. After the stair is placed, the stair information label is automatically displayed, showing details such as the number of risers, riser height, and tread depth. At the same time, the label of the stair is automatically defined. There are 3 different lines in the stair area. The innermost dashed line represents the concrete structure of the stair. The middle dashed line represents the riser covering. The outermost solid line represents the stair nosing, the protruding front edge of the tread. Since the concrete and riser coverings are below the stair surface, they are shown as dashed lines in the drawing. The line representing the nosing is considered the visible edge of the stair and is drawn as a solid line. The selected stair type has symmetrical flights. The stair settings can be reopened by double-clicking on the stair. This action opens the Stair Edit dialog. After the stair is placed, additional tabs become available in the Stair Edit dialog, such as Parameters, 2D View, 3D View, and Areas. These new tabs allow detailed placement properties of the stair to be edited. In the Parameters 2D View tab, the flight width and length, landing width and elevation, and overall stair height can be adjusted. In general, all dimensional properties, such as total width and length, are modified from this section. The available parameters may vary depending on the selected stair type. The stair can be examined in detail from the 3D View tab using the perspective window. If needed, the inverted stair option allows the stair's exit direction to be changed easily. When the selected construction type is string, the string elements can be shown or hidden using the Hide Stair Cheek and Show All Cheeks option. If any modifications are made to the railings, the Reset Balusters option can be used to discard all changes. The Construction tab includes the same settings introduced earlier. However, since the stair has now been placed, new options related to covering lines are also available in this section. These settings can be adjusted as needed for the project. The Areas tab provides a list of the stair's individual segments. Each segment can be customized separately, allowing different tread settings to be applied to each part. Stair design is based on three main parameters: number of step, riser height, and tread depth. These three parameters are interdependent. When one is modified, the other two are automatically recalculated to maintain a consistent and functional stair configuration. For example, if the number of step is set to 8, the riser height and tread depth will be automatically recalculated. If a riser height of 17.5 centimeters is entered manually, the software determines the appropriate number of treads based on that value. In this example, a U-shaped stair is selected. Structurally, it consists of 2 stair flights and 1 landing. As a result, the list includes flight of stairs 1 and flight of stairs 2, while landings are not listed in this section. If the stair flights in your project are not symmetrical, for example, if one flight requires 7 treads while the other needs 8, there are 2 options. Either a new stair can be created or the existing stair can be modified by applying deformation to extend one of the flights. At this stage, stair deformation will be applied to extend one of the flights by adding an additional tread to the existing stair. Let's create a reference line for the tread. Click the Multiple Lines command from the Drawings tab. This reference line will represent the position and width of the tread. After specifying the first point, press the L key on the keyboard to activate the length field in the coordinate box. Enter 28 centimeters as the tread depth and press Enter to fix the line. Continue drawing and complete the tread by connecting the final point. This drawing will function as a visual reference for the new tread to be added. The purpose of drawing this step is to provide reference points during the deformation process, allowing the stair to be extended more easily and with greater control by snapping to specific nodes. From the Home tab, click on the Stair command. Then select the Deform Stair command from the toolbar. Once the command is activated, the Stair Deformation toolbar appears on the screen. On the plan view, certain nodes on the stair become more prominent. These points represent the boundaries of the stair's concrete structure and can be used for the deformation process. First, move the cursor over the node you want to edit. When the cursor changes to a check mark, it means the point is active. Click to select the node, then drag it to its new position. The stair will automatically be reshaped according to the new geometry. Repeat the same process for the second node. Once the deformation process is completed, the stair railings are automatically adjusted to fit the new geometry. This ensures that both the concrete structure and the railings are updated accordingly. After the operation, the stair's information label is updated to indicate that the stair now includes treads with different widths. For example, one segment may display a tread depth of 28 centimeters, while the other shows 32 centimeters. This variation occurs because the stair flights have different lengths after the deformation. To maintain the overall height and fit the geometry, the software automatically recalculates the tread depths for each segment. However, this outcome is not ideal. For user comfort and safety, stairs should maintain consistent tread depths and riser heights. Inconsistencies can disrupt the rhythm of movement and may pose safety risks. Therefore, when deformation is applied, it is essential that this balance is maintained. Ideally, the required number of treads should be added to a single stair flight, and the landing elevation should be adjusted to ensure consistent dimensions across all flights. Double-click on the stair to open the Stair Edit dialog. Go to the Areas tab and select the second area, as the modification was made on the second flight. Update the tread defining parameter to 8, since one additional tread is needed. As a result, the tread depth is correctly adjusted to 28 centimeters. Switch to the Parameters tab. Since the total stair height is 280 centimeters and an extra tread has been added, the riser height is automatically recalculated as 16.47 centimeters. Adjust the landing elevation to reflect this change. In this case, the elevation should be entered as 131.76 centimeters. After confirming the value, the information label in the preview window will update and display properly in a single line. Finally, click the OK button to confirm the changes and complete the stair design with the desired and consistent dimensions. If the stair railings need to be hidden, the Show Hide Railing command can be used. With this command, the selected railing area is made invisible. Likewise, any railing that needs to be displayed again can be made visible by clicking on the corresponding area. This operation can be easily performed within the plan window. Depending on the stair design, it may be necessary for the spacing between railing profiles to be adjusted. In the ideCAD, railing profiles are automatically placed at predefined intervals. To decrease the spacing and add more profiles, the Change Baluster Count command is clicked. The desired railing to be modified is selected. In the dialog box that appears, the new number of profiles, for example, 12, is entered. By clicking OK, the program updates the profile placement according to the specified count. This process can be applied to each railing segment individually, allowing the railing layout to be adjusted in accordance with both regulations and design preferences. After reviewing the modifications made to the existing stair, let's now create a new stair. This method is especially useful when custom-designed stairs are being modeled or when non-standard stair configurations are required. With this approach, a stair can be constructed step by step according to specific design requirements, and each segment can be customized individually after placement. To create a new stair, the Create New Stair command will be used. In order to perform this operation, the outer boundaries and the line of travel must first be defined using two deguide objects called Path. From the Drawings tab, the Path command located under the Primitive section is selected. There are three path types: straight, arc, and curved. The straight type is selected. First, the outer boundary of the stair is drawn. For convenience, previously drawn guidelines can be followed. Next, the stair's line of travel is drawn, ensuring that its start and end points remain within the stair boundaries. Once the line of travel is complete, a right-click is used to exit the command. Then, the Home tab is opened and the Create New Stair command under the Stair menu is clicked. The previously created outer boundary and line of travel are selected. The Stair Area dialog will open, and the stair area will be displayed in the preview. A suitable type is selected from the Type section. In this example, the stairs are selected as the preferred type. For instance, a stair with 4 treads and a total height of 70 centimeters is specified. A preview of the treads is generated based on the input. After other parameters such as thickness and railing height are adjusted, the OK button is clicked. The stair treads are now defined. When creating a new stair, straight forms are not the only option. Curved stairs can also be defined using arc-shaped lines. To do this, the Path command is used once again. From the Drawings tab, click on the Path command. If the first edge will be straight, begin with a straight path. Click the relevant points to define the outer boundary. To transition to a curved segment, switch the path type to curved and draw the curved edge. Once the curve is complete, right-click to confirm. Then, switch the path type back to straight and draw the straight edge. Next, switch to curved and continue drawing the curved edge. Clicking the last point automatically ends the command. There's no need to right-click again. Next, draw the line of travel. With the curved route type selected, click the necessary points to define the path. Right-click to complete the drawing. Now that the outer boundary and the line of travel have been defined, the stair can be created. From the Home tab, click on Stair, Create New Stair command. First, select the outer boundary, then select the line of travel. Based on the previously defined inputs, the system will automatically generate the curved stair. In curved stairs, tread depth plays a key role in shaping the curve. Increasing the number of treads results in a smoother and more aesthetically pleasing curvature. Once all adjustments are complete, click the OK button. Your curved stair will be created. Let's also create an example of a winding stair. To create a winding stair, we'll once again use the path command to define the outer boundary and the line of travel. Click the path command to begin defining the outer boundary. Set the path type to straight. Draw the outer boundary of the stair. Then, draw the line of travel and right-click to complete the command. Click on Create New Stair. First, select the outer boundary, then the line of travel. Let's create a stair with 10 treads and a total height of 165 centimeters. Click the OK button to generate the winding stair. Suppose you want the first 2 steps to be straight, followed by a turn. Double-click on the stair to open the Stair Edit dialog. Go to the Areas tab and navigate to the Balancing and Standards section. Enter 2 as the unskewed riser count at start. This setting ensures that the first 2 treads remain straight and the winder portion begins afterward. You can preview the result in the 3D view, then click OK to finalize the changes. The first 2 treads of the stair will be straight. In this way, various types of stairs tailored to your design needs can be created efficiently. Let's recreate the stair used in the training steps. This stair is a U-shaped configuration with 3 flights, 2 landings, and a total of 17 risers. We'll begin by using the path command to define the outer boundaries and the line of travel. Click on the path command. Start by drawing the first boundary with a stair flight width of 120 centimeters and length of 150 centimeters. Then, define the line of travel for this area. While creating the second stair area, the landing, you'll notice that the second stair area is centered relative to the landing. One of the most critical aspects when creating new stairs is aligning the nodes precisely. For the stair areas to connect properly, it's essential that the nodes align correctly. Therefore, when drawing the second area, do not draw the shared edge in a single step. Instead, place nodes exactly where the nodes of the first area are located. After defining the boundary, continue by drawing the line of travel. Repeat the same steps for the remaining 3 areas. First, define the outer boundaries of each stair area. Then, draw the lines of travel, making sure that the start and end points lie precisely on the stair boundaries. This ensures accurate connections between all stair segments. Once all boundaries and lines of travel are defined, click on the Create New Stair command. First, select the outer boundary and then the line of travel. Enter 5 as the number of treads and 105.84 centimeters as the total height. Click the OK button to complete the creation of the first stair area. Since we are adding new areas to the existing stair, we will now use the Add Stair Area command instead of Create New Stair. Click on Add Stair Area command. First, select the existing stair, then choose the outer boundary and the line of travel. The new area will be added to the previously defined stair. Select the appropriate landing type and click OK. Click the Add Stair Area command once again. Then, select the existing stair to which the new area will be added, followed by selecting the outer boundary and the line of travel of the new stair area. For this area, enter 4 treads and a total height of 88.2 centimeters, then confirm the settings. Repeat these steps to define the next landing and the final stair area, which will include 5 treads and a height of 105.84 centimeters. Once all stair areas have been added, the U-shaped stair with 3 flights and 2 landings will be complete. When the stair is generated, the riser height is calculated as 21.17 centimeters. This happens because the final tread is placed at the same level as the landing or ceiling, reducing the riser count. However, the intention was to use the landing itself as the final step. To achieve this, open the Stair Edit dialog. Go to the Areas tab and deselect the Top Tread is at Ceiling option for the first stair area. The software will then automatically recalculate the riser height to match the intended configuration. Apply the same adjustment to the other 2 stair areas as well. With this setup, the first 2 landings now act as the final treads of their respective stair areas, and the top stair area is defined to connect directly to the story slab. After completing the adjustments, close the dialog. Since the riser heights and tread counts are now consistent across all areas, the stair information label is displayed collectively in a single location. Based on a total of 17 risers and a total height of 300 centimeters, the riser height will be automatically calculated as 17.64 centimeters. The railings of the stair will be hidden by using the Show Hide Railings command. First, the Show Hide Railing command is activated, and then the hidden railings are clicked to be made visible. Press the Escape key on the keyboard once the hiding process is completed. With this, the stair creation process has been successfully completed. Thanks for watching. Don't forget to like, subscribe, and explore the knowledge base for more tips. See you in the following video.